using MATLAB. So, in this lecture we will discuss about the ordinary differential equation, how to solve the ordinary differential equation using MATLAB. Today very interesting concept. Today we will discuss about how to solve an ordinary differential equation using MATLAB programming. So, particularly we will use very important function dsolve function. So, we will use the dsolve function for finding the ordinary differential equations. So, what is dsolve function, how to apply, we will discuss in this lecture. So, now coming to very important point. First we will discuss about what is ordinary differential equation, then we will discuss about how to find the solution of the ordinary differential equation using MATLAB programming. An equation involving differential coefficients is called a differential equation. So, differential equation is an equation which contains differential coefficients like dy by dx, d square by dx square and x and so on. So, first example of an ordinary differential equation is d square by dx square plus 3 dy by dx plus 2y equals to sin 2x. In the similar way, another differential equation x dou z by dou x. So, here a small mistake, dou z by dou x plus y dou z by dou y equals to nz. Okay. So, now both are equations and also it contains differential coefficients. In first example, whose coefficients are ordinary derivatives. In second equation, whose coefficients are differential coefficients are partial differential coefficients. Okay. Now, coming to types of differential equation. We have two types of differential equation, mainly we are classified into two types of differential equations. One is ordinary differential equation and other one is partial differential equation. So, ordinary differential equation. An ordinary differential equation is one which involves only one independent variable. So, if you observe this example, x is an independent variable, only one independent variable. Now, this equation is called an ordinary differential equation. But in second example, a partial differential equation is one which involves more than one independent variable. Here x and y are both independent variables in example 2. So, this is called partial differential equation. But in this lecture we will solve the ordinary differential equation. In the future lectures we will discuss about the solutions of partial differential equations. Okay. Now, coming to how to solve the ordinary differential equation using dsolve function. So, before going to the MATLAB programming, okay, just I will explain few lines. Suppose if you have a differential equation dy by dx equals to f of x y. This is a first order differential equation. You know about the how to solve the differential equation. What are the known methods? Suppose if it is variable and separable, separating the variables x and y, then apply variable and separable method. If it is homogeneous function, f of x y is a homogeneous function, apply the corresponding method. If this differential equation is first order linear differential equation, then solve the first order differential equation. If it is exotic differential equation, apply exotic differential equation. Suppose if you take a second order linear differential equation 3 dy by dx plus 2 into y equals to 0, this is second order linear differential equation. So, for solving this second order linear differential equation, find the complementary function and particular integral. Here there is no need to find the particular integral because right hand side is 0. So, these methods are analytical methods. Now, we will discuss another very important tool for solving such a differential equation without finding the analytically. We can solve such a differential equation with the help of a very important tool. Such tool is called MATLAB programming. So, with the help of MATLAB programming, we can solve such ordinary differential equation, whether it is first order or second order or higher order. We can solve the differential equation with the help of MATLAB programming. We have variety of methods. So, in this lecture, we will discuss about very important function, dsolve function. So, with the help of dsolve function, we can solve such ordinary differential equation easily. We can solve it. So, now we will discuss about what is the dsolve function, what is the syntax, then how to apply the dsolve function. We will discuss one by one. So, now observe. Wait, sorry. Now, so dsolve is a built-in function. Okay, dsolve function. So, if you write an equation inside, then easily we can solve the ordinary differential equation without any conditions. Suppose if you have some initial conditions, very simple, again dsolve function, write the equation, then comma, write the conditions. In the similar way, we can solve system of differential equations also. Okay, I will explain one by one. Now, this is very simple syntax, dsolve of equation or dsolve of equation with condition. Suppose if you are dealing with initial value problem, for example, I will show you. Suppose second order linear differential equation is given and also given y of 0 equals to 1 and y dash 0 equals to 2. Then how to solve the differential equation? Just very simple method, analytical method. Solve the differential equation. You will get the solution in terms of C1 and C2. For finding C1 and C2, substitute these two initial conditions. Okay. Again, we can solve such a differential equation with the help of dsolve function. Now, I will explain the methods. Okay. Now, very simple methodology. In place of dy by dx, simply we will use diff function y comma t. Y is a function of t. So, first declare the symbolic notation y of t, then write diff function diff y comma t in place of dy by dx. In place of d square by dt square, use diff of y comma t comma 2. This 2 denotes the second order derivative. Suppose if it is third order derivative, d cube y by dt cube. Now, very simple notation, diff y comma t comma 3. So, this is a simple notation for solving ordinary differential equation. In place of dy by dx, we will use the diff function. D square by dx square is 1, d cube y by dt cube is this function, and finally write the given equation in terms of diff function, then substitute this equation in place of dsolve function. Directly you will get the solution. I will explain with an example. Okay. Now, coming to this example, now listen carefully. Dy by dx plus y minus x equals to y minus 1 into cos x equals to e power sin x, e power sin x Now, observe this differential equation, dy by dx plus y minus 1 into cos x equals to e power sin x into cos square x. Now, what is the methodology? Direct method. Now, observe, this is look like, I will rewrite the equation. dy by dx plus y into cos x equals to cos x plus e power minus sin x into cos square x. Now, this is first order linear differential equation. Find the integrating factor and finally find the solution of the differential equation. That one is analytical method. Now, with the help of dsolve function, then how to find the solution? Okay. Okay. Now, listen. Now, if you observe this problem dy by dx, in place of dy by dx, what is the methodology? Diff function, diff, and before that first you write the symbolic notation y of t. Okay. Now, write the equation dy by dx. In place of dy by dx, write y comma t plus, okay, in place of y minus x, y minus 1, then multiply with cos x. Cos x function is cos of x equals to, but here in place of equals to, use double equals to. Now, e power exp exponential function of minus sin of x into cos square x, cos x whole square. Now, assume this total equation equals to some ODE or any name. So, observe this equation, ODE equals to this one. This is nothing but dy by dt. Okay. You may write in terms of t or in terms of x, then no problem. If you take symbolic notation y of x, you will get y of x, or y of t, then no problem. You will get the same solution. Now, second term is y minus 1. Here y minus 1, write y minus 1, cos x, okay, cos t, then no problem. In place of equals to symbol, use double equals to, logical equals to, and exponential function of minus sin t plus cos t whole square. Now, this is the given differential equation. So, I will call it as ODE. Just name, my name is ODE, you may call any name. Now, solution. Okay, I will call it as y solution equals to, use dsolve function and ODE, then directly you run the program, you will get the solution. Okay, I will explain in MATLAB software. Okay. Okay. I will copy the code just for understanding. Just I will copy the code in our MATLAB software. Open a script file. Okay, fine. Open a script file. Now, observe y of t, you may call it as y of x also, then no problem, you will get the same answer. ODE, any name, not only ODE, now call it as any your desired name. At the end, I will call it, I will take semicolon. Okay. So, dsolve of this equation, already we discussed it, then how to write the equation, very simple. Before run the program, now save the program in our desired folder. Okay. I will call it as problem 1, probe 1. Okay. Now, it is called it as probe 1. Okay. Okay, then no problem, I will take underscore, otherwise you can't read it. Pro underscore 1. Okay. then no problem. CLC, clear the screen. Now run the program. So before that, I think good practice is clear all CLC, clear the workspace and clear the command window. Okay. Just run the program, you will get the solution. Just wait, depending on the computer speed, you will get the solution. Now observe, you will get the solution directly. If you run the program, very easily, only one line code, give the differential equation. In place of dy by dx, use the diff function, directly you will get the solution. Now this is first problem. So in second problem, directly you will get the solution. Okay, directly you will get the solution. Now second problem is, okay, I will write the program in terms of y by t, dy by dx or dx by dy, then no problem, you will get the same solution. Okay. Initially I will use y and t only, later I will use yx also. Okay. First rewrite the equation. Suppose a differential equation is given, then how to rewrite the differential equation in terms of dx by dt. dx by dt. Now if it goes to right hand side, x tan y minus secant x dy by dx equals to minus 1. X tan y minus secant x equals to minus dx by dt. Okay. If it goes to left hand side, dx by dy, dx by dy equals to plus x tan y minus secant x, okay, equals to 0. Now how to write our code? Okay, now I will call it as ODE1. You may write any one. First declare symbolic notation sims of y of t. Okay, in place of x I will write y, in place of y I will write t. So what is the equation? dx by dt, diff function of y comma t. You may write in terms of xy, then no problem, you will get the solution in terms of xy, don't worry. Plus, so y into tan t minus secant t. Now in place of equals to, use double equals to, then apply. Now finally use semicolon, then use dsolve. You may write any one, y equals to dsolve of ODE1, write the equation here, directly you will get the solution. Okay, we will discuss in our software. Okay. I will write in our software. First I will save the program. Pro 2. Okay. I will save the program. At the end I will write, okay, a small problem in my drive, that's why I got some errors. Okay. Okay, I will change the directory. I think better to solve. Okay, I will change the directory. Better. Okay. I will change the directory. Okay. Now run this program. Very easy. Directly you will get the solution. But the analytical methods, this is a linear differential equation. It will take more time for solving this problem. Directly you will get, you may give any name in place of dsolve before the dsolve, or without name, then no problem, you will get the same solution. Okay, I will write again, I will run again. You will, in place of answer, you will get y. Yes, very simple. Okay, suppose if you want to replace with x by t, then no problem, you will get the solution in terms of x, not only yt. Okay. So you will get the solution in terms of yx also, not only yt, y of t, yx also, or x of t by any variable, we can change it, then no problem. Okay. So good practice is clear all and CLC. Okay. Okay, I will run again. Wait, you will get the solution. So you will get the solution, very easy. Now coming to third question. Now third question. Second problem is already completed. Now third problem, check it. Now listen. Now this is fourth order linear differential equation, not only first order. So previous two problems are related to only first order differential equation. Now this is fourth order linear differential equation. Then how to solve this differential equation? Very simple. In place of fourth order differential equation, use diff y comma x. Fourth order means replace this number 4 plus 8 into second order, use diff function y comma x comma 2 plus 16 into y double equals to 0. I will call it as some name ODE 3. Okay. So first equation is given with semicolon, same differential equation is given. Then apply dsolve function for this ODE 3. So simply use dsolve function, directly you will get the solution. So very simple. Now this equation contains 4 variables C1, C2, C3, C4, and okay, you will get the solution directly with simple code using dsolve function. Now I will show you on software. Now very simple. Okay, in our software, take a new, so clear all, CLC also, I will write CLC. So, here bracket is missed, here use semicolon. Okay. You will get the solution without now save the problem pro 3. Okay. Pro 3. Okay, I will clear the screen, CLC. Now run the program. This is fourth order D in terms of x or t, then no problem, you will get the solution. If it is y, if it is t or x, you will get the corresponding solution, don't worry. Directly you will get the solution which is shown in our slide. Okay, directly you will get the solution with 4 variables. Very easy methodology. Now coming to fourth question. Now this is also same procedure. I think no need to run the program in our software. Just I will show you here how to write the code. Now first multiply all these things. So this is d plus 2 into d minus 1 whole square of y equals to 2 sin hx. So multiply d plus 2 into d square minus 2d plus 1 into y equals to 2 sin hx. Okay. So multiply d cube, d square term minus 2 and plus 2, both are cancelled. Now d coefficient, here d 1 into d and minus 4d. So minus 4d plus 1d is minus 3d, minus 3d, constant is plus 2 into y equals to 2 sin hx. So this is nothing but d cube y by dx cube minus 3 dy by dx plus 2y equals to 2 sin hx. So in place of third order derivative, use the diff function. Now listen, this one, diff y comma x. Okay, I will write a symbolic notation y of x, then no problem, comma 3. Next 3 into diff function only dy by dx plus 2 equals to 2 sin hx. If you run the program using dsolve function, dsolve of this name of the equation, directly you will get the solution. Now in place of equals to, use double equals to, logically equals to. Now coming to fifth question. Now this is another very interesting question. So this is a third order linear differential equation with some coefficients are given. Then how to write a code? Very easy. In place of y triple dash, now use, okay, I will call it as ODE 5 because this is fifth question. Okay, I will write it as 5. So y triple dash is nothing but diff function of, first I will write symbolical notation y comma x or y of t, then no problem. Symbols. Okay, diff function y comma x comma 3 minus 6 into y double dash is nothing but diff function of y comma x comma 2 plus 11 times of diff function of y comma x. No need to write 1, not required, minus 6 into y double equals to 0. So I will call it as equation number ODE 5. Okay. Now some conditions are given. What are the conditions? Now observe these 3 conditions. Now observe. Some 3 conditions are given. So how to substitute the values in our dsolve function? Okay. I will solve in our software. Just I will explain. Okay, 0, 0, 2. Conditions are 0, 0, 2. So I will write in software, right. Okay, fifth question. No. So, what is the procedure? Yes, Y, M, yes. So, before that write clear all CLC. Now, Sims, okay, I will write it as Y of X. So, ODE, okay, write any name, ODE 5 or 6, whatever it may be, then no problem, equals to diff function Y comma X Y comma X fourth order derivative, then what is the next term? Minus 6 into diff function of second order derivative. Okay, fine. Second order means comma 2. Okay, next term plus 11 into diff function of Y comma X. Okay, then minus 6 Y, minus 6 into Y double equals to 0. Okay, I will use semicolon. Okay, fine. Now, actually, directly if you want the solution, directly substitute the value Y equals to dsolve of ODE 5. But you will get the solution in terms of some constants, but some initial conditions are given. What are the conditions? Y of 0 equals to 0, Y dash 0 equals to 0, Y double dash 0 equals to 2. Then how to write? Okay, very simple. First, some name I will write Y1 or anyone, write any name. Y1 equals to diff function of Y comma X. Okay. Y2 means second order derivative, diff of Y comma X comma 2, second order derivative, and also I will call it as some name Y3 equals to diff of Y comma X comma 2. Just I will verify it. Question. Okay, first Y of 0 is given. Okay, then no problem. Y of 0 is first order and second order derivative. Okay, so third one is not required. Because Y of 0 is given, Y dash 0 is also given. Then condition. Okay, you may write any name. Condition. What is the condition? You may write in vector form, or okay, you may write in vector form, or write directly in our dsolve function. Okay, what is vector function? First, Y of 0 equals to Y of 0 equals to 0, comma Y1 of 0 is also 0 is given, comma Y2 just name inside is x value equals to 2. I will check it. Okay, two values given. Okay, so I will write closing with semicolon. Now write COND. Write any name, then no problem. Not only COND, you may write CONDA also, then no problem. Now save this program. Profile. Profile. Then run this program. Okay, directly you will get the solution. Okay, whatever it may be, you will get the corresponding solution. Minus 6, 11, minus 6. Okay, I will check it. Condition, what is the condition? Y double dash is 2. Okay, fine. Okay, fine. Fourth order. Wait. Oh, sorry, it's in a small mistake. Okay. This is third order. In our problem, third order. If it is fourth order, same methodology, don't worry. Okay, third order, that's why you got another answer. Our answer is not matched. Okay, I will run again. So in the now you will get e power 3x minus 2 into e power 2x plus e power x is the solution. That one is our answer. So now coming to another very important concept. Suppose if you are dealing with some engineering problems, particularly electronics and communication engineering or electrical engineering problems, then how to solve the engineering problems with the help of dsolve functions. Now I will explain engineering problems. Okay. Write a MATLAB code for the following problem. The initial value problem governing the current I flowing in series RL circuit when voltage T is applied given by Ri plus L di by dt equals to T. Find the current at any time T. Okay, I will show you. Wait, I will explain the question. Okay, third question is completed and fourth question is also completed. Fifth question is also completed. Now coming to engineering problem. Okay. Suppose R resistor and inductor are connecting in series. Some input is given. Okay, this is input, this is resistor, this is inductor. Okay. Now what is the current? Now this is I is current, current flowing in this circuit. Now what is the current at any time? So simply we are using the Ohm's law. First convert into the, suppose the circuit is given, convert into the differential equation, then solve this one. So what is KVL law? So with the help of Ohm's law, we can find the voltage drop across resistor. In the similar way, we can find the voltage drop across inductor. By KVL law, applied voltage E equals to voltage drop across resistor and also voltage drop across inductor. So, E equals to VR, V equals to Ri plus the voltage drop across inductor is L di by dt. Okay, this is a differential equation. This is the differential equation in terms of di by dt, di by dt into L plus Ra equals to sum E. So, the corresponding differential equation is given. So, then how to solve this differential equation with the help of MATLAB programming. So, very simple. Here I dependent variable, t is independent variable, that is why we are giving, okay, I will zoom it. Okay. Now, what is the code? SYMS, okay, I of t, I will call it as a sum name. This is a RL circuit, I will call it as RL equals to R into I plus L into di by dt, replace the di by dt with diff function I comma t. Then equals to double equals to use t. So, directly you will get this code and some initial condition. There is no initial current inside the before performing this experiment. Okay, I will take it as I of 0 equals to 0. Okay. So, for this purpose here we are giving directly dsolve of this function, directly you will get the solution. In the similar way, I will explain with another problem. Okay, another problem is second engineering problem, same procedure. Write a MATLAB code for the following problem, similar question. Write a MATLAB code, okay. Write a MATLAB code for the following problem. An EMF is applied to a series circuit containing 2 ohms resistor and 0.01 farad capacitor. Find the charge and current at any time if there is no initial charge on the capacitor. Okay. So, first resistor and capacitor, okay, are connecting in series, some voltage is applied, battery is connected to these two, I is this one, this is R, this is C. Now, again apply KVL law. So, E equals to Ri using Ohm's law. Then voltage drop across capacitor. Voltage drop across capacitor is Q by C, charge by capacitance. Now, and also we know that I equals to dq by dt. So, replace I by dq by dt, then what happen? E equals to R into dq by dt plus q by c. Q by c. Now, this is an equivalent differential equation for RC circuit. For RC circuit, then what happen? What is the equivalent code? First, initially in this program, clear all CLC symbols. Now, this is the Q is a function of t, and R and L R value, some R value is given, and C value is also given, R equals to 20 ohms, and C value is also given. Okay, give the input values. Now RC circuit. Now equation R into dip function of Q comma T plus Q by C equals to double equals to E value is given. E value is given 200 into e power minus 5t. On initial condition there is no charge, so that's why I will write Q of 0 equals to 0, and this is condition, this is RC equation, this is RC equation, this is the condition. Simply apply dsolve function, directly you will get the solution. Okay. In the similar way, now similar question, LCR circuit. Okay. Write a MATLAB code for the following problem. A condenser of capacity C discharging through the inductance L, resistance R in series, charge Q at any time satisfying the equation L d square Q by dt square plus R dq by dt plus Q by C equals to 0, given that L value is given, R value is given, C value is given, and also T value when T equals to 0, Q of 0 equals to some 0.02 is given, and also dq by dt is also initial condition, Q dash 0 equals to 0 is given. In this particular problem, now convert into the equation MATLAB code, then apply dsolve function. So here Q of t entirely in terms of Q of t, that's why symbols Q of t. R value is given, L value is also given, C value is also given, just write the corresponding values. Now equation, now I will call it as LCR. Okay, I will call it as LCR, L into second order derivative d square Q by dt square plus R into first order derivative plus Q by C equals to 0. Now for applying the first order derivative, I will call it as dq or any name, then no problem. Dip of Q comma T. So condition is first Q of 0 is 0.2 is given, and this equation substitute 0 at 0, this value is also given, Q dash 0 is 0. So directly this is condition, then finally apply dsolve of LCR comma condition, then directly you will get the required charge. Suppose you after finding the charge, after finding the charge, if you want to know the I value, I equals to dq by dt. Suppose if you want to know the current after finding the charge Q, simply find the derivative with respect to t, you will get the current. So if you want to find the current, very simple, after finding the Q value and differentiate with respect to t, you will get the current. Okay. Now coming to fourth engineering problem, same procedure, similar procedure, some conditions are also given, same methodology. So here applied voltage is E into sine Pt. So okay, here I am through dividing L, then actually not required, directly you can solve it, and initial conditions are also given. Q of 0 is given, and dq by dt is also given, same similar to the previous problem, you will get the same question. Okay. Now another engineering problem, very interesting concept, actually this is quite related to mechanical engineering problem, thermal engineering problem. Write a MATLAB code for the following problem. If the air is maintained at 15 degrees Celsius and the temperature of the body drops 70 degrees to 40 degrees in 10 minutes, what will be its temperature after 30 minutes? So here we will use Newton's law of cooling. So what is Newton's law of cooling? The temperature of the body at any time is directly proportional to the temperature of the body, the difference between the temperature of the body and surrounding media. So dt by dt is proportional to T minus T naught. T naught is the surrounding temperature. Surrounding temperature is given in this problem. Surrounding temperature is 15 degrees, that is T naught value. So if you remove the proportional constant, okay, I will write it as K. dt by T equals to K into T minus Tt, and also initially the temperature initially the temperature T of 0, initially the temperature of the body is 70 degrees. After 10 minutes, it cools down to 40 degrees. This is T of 10 equals to 40. After 10 minutes, the temperature of the body is 40 degrees. Okay. Now we will solve this differential equation with the help of our MATLAB tool. Okay, but here K is unknown quantity. We don't know at this moment. At this moment, we don't know about the K value. T naught is also known, 15 is known. Then first we will find the K value, then we will find the actual solution. For this purpose, the total program is divided into two parts. This is first part and this is second part. This is first part and second part. What is first part? In first part, we will find the K value. Later, we will find the actual solution. Okay. For solving this problem, so T is a function in terms of T. T is a function in terms of T. K is also constant. Okay. Now write the equation. I will call it as some name. Diff function of T comma capital T comma small t double equals to K into T minus T naught is 15. So some condition is also given. T naught equals to initial condition. This one. This is initial condition. 70 is given. Then apply dsolve function, and you will get the solution. Actually, you will get the solution in terms of K only. I will show you in this software up to this part 1. Then we will find the solution. Okay, wait. I will explain in our software. Okay, I will copy the question. I will copy the code. Okay. Up to this first part, just see it. Okay, problem, some name, Pro 6, I will call it as Pro 6. Pro 6. Okay. CLC. So, diff function is given, the differential equation is given, some condition at 0 is also given. Just if you run the program, you will get the solution in terms of K only. Just observe it. So, you will get the solution in terms of K only, some equation in terms of K only. So, we don't know about the K value. For solving the K value, again write another code. What is the code? Use solve function for finding the K value. So, K equals to solve solution of at, so T equals to 10. Now, we are applying second condition at T 40 degrees. Solve 10 equals to 40, then you will get the K value. You will get some K value. If you solve this equation, you will get the K value. Okay. After finding the K value, now again substitute the K value, again repeat the same 3 lines, again 3 lines, you will get the final output. Now, this one NCL1, remaining 3 lines are same as the previous one. After finding the K value, just substitute the K value in place of this equation, just to solve it, you will get the required solution. Very easy. So, first find the K value, then again repeat the same differential equation, or you may use any condition or any looping concept, directly you will get the solution. Then don't worry, very simple concept, directly you can write it. Very easy. In this next question, now another method. This is actually This is another methodology for solving dsolve function, but in our new MATLAB software, it may drop in the next versions, it may not work in the future versions. So, that is why just I am explaining the previous methodology for finding the solution. Very simple, dy by dx. In place of dy by dt, simply write dy equals to, under single quotes, write this equation entirely, and under single quotes write the condition, and finally variable is t. Then apply this dsolve function directly, you will get the solution. This is old methodology. Okay. Now coming to second order differential equation, write in place of d square y by dx square, use d to y. In place of dy by dx, use dy. Now equals write under single quotes, and condition is under single quotes, and also second condition also under single quotes, and also write the variable. Then press enter, directly you will get the solution. So, no need to write in our script file, directly we can write in command window, directly you will get the solution. Okay. Now, in the similar way, another question, d square by dx square, in place of d square by dx square, d 2y plus 2 into dy by dy plus sin x, under the single quotes, and again write the conditions under single quotes, and also finally write the variable independent variable x, directly you will get the solution. Okay. Now, with the help of dsolve function, we can solve easily, we can solve the ordinary differential equation with the help of dsolve function. If you have any doubts, then write in our comment box. So, okay, in our comment box write our feedback. So, if you have any doubts, ask me. So, my WhatsApp number is 98662 78504. So, I will write here. My WhatsApp number is 9. Right. 98662 78504. Okay. Thank you very much for patient listening. Meet again in our next lecture.